So for number one here, finding the domain of rational function, we know with all rational functions we have the potential, because we have a polynomial divided by a polynomial, that we could have a denominator that equals 0. So any real numbers that make the denominator 0 are not allowed to be in the domain. All other real numbers are allowed to be in the domain. So when we set this denominator equal to 0, we get x equals -3. So we say x is not allowed to be equal to -3. So that would be our domain, x, all values of x such that x does not equal -3. So there's our domain. You should also realize that since this factor of x plus 3 did not get canceled, if we were to graph this function, that x equals -3 would be a vertical asymptote. So any real number that makes a denominator 0 is either going to be a vertical asymptote or a whole. That's for rational functions. So then if we look at this denominator here, x squared plus 1, x squared plus 1 will always be a positive number. Therefore, domain is all real numbers, because this denominator can never be 0. When we see a denominator that's a quadratic expression, we want to go ahead and factor it, x plus 8, x minus 5. And when we set each factor equal to 0, we could see that x is not allowed to be equal to -8, nor is it allowed to be equal to 5. So all real numbers besides -8 and 5.